Now let's look at circle theorem. And to start out, let's define what a circle is. A circle is a round figure whose boundary, which is the circumference, consists of points equidistant from a fixed point, the center. What this means is that in a circle, you have the center and you have several other points that have a fixed distance from the center to all those other points. So that's what a circle is. So what are some of the parts of a circle? So first we have the radius, and the radius is the line that connects the center to the circumference. You have a chord. A chord is a straight line that divides the circle into two unequal halves. Then you have the diameter. Diameter divides a circle into two equal halves. Then you have the tangent, which is a line that is just drawn to touch the circle, the circumference at any point. Then the circumference refers to the outline or the boundary of the circle. Then you have the segment. The segment is the space within the area bounded by a curve and an arc. While an arc is just a section of the circumference. So when I pick a small fraction of the circumference, it's called an arc, and a semicircle is half of a circle. Now a sector is the area bounded by two radius or two radii and the arc. So this shaded region here represent the sector, then the segment, and the sphere is a three-dimensional circle. So let's talk about the chord of a circle. So when I draw a circle, as you can see here, and I have a chord, as you can see, this line over here represents the chord. So if I draw a straight line from the center of the circle to cut the chord into two equal halves, then the angle between the chord and that line is going to be what? 90 degrees. So the angle here and the angle here is, they are both 90 degrees. Now if I draw a line from the center to the edge of any of the chord, as you can see, that line is from the center and is going to touch the circumference. So that line also represents the radius of the circle. So a line drawn from the center to the edge of a chord is the circumference of the circle. So let's look at some of the properties of circle. And the first one, or the first three we are going to talk about, are the arc properties of a circle. So the first property says that inscribed angles subtended by the same arc are equal. What this means is that if I have an arc, for example, you can see that this line segment from A, this curve segment from A to B is an arc. So from that arc, if I draw two lines that touch the circumference at any other point, for example, I have this green line, blue line over here that comes here, that the angle that is subtended is equals to the angle that will be subtended if I draw any other line in such manner. So for example, in this black line, I draw the line from here to here. The angle here is same thing as the angle here, and that here also is same thing as the angle here. So provided that the starting point is from the edges of the arc, any line I draw, the angle subtended is going to be what? Equal. So for example, let's consider that I have a circle, and in that circle, I have an arc from here to here, and here now I have something like this from here that comes here, and at this same starting point again, I have another angle that comes here and that ends here. Now, and I'm told that the angle here is 30 degrees, and I marked what is this angle here. As you can see, both of those lines are originate from the same point on the arc. So both of them originate from here and here. So therefore, the angle subtended on the circumference must be equal. So if here is 30 degrees, here also must be equal to 30 degrees. So now the second part tells us that the angle subtended by the diameter or semicircle is 90 degrees. So now let's assume that instead of having just an arc, I have an arc in which the chord there is a diameter. So the arc is like half of the circle. So in this case, the angle that is subtended on the circumference is what? Is 90 degrees. So for example, if I have a circle like here over here now, and I have a line that passes through the center, which is the diameter, and this is center O, and I draw a line like this, the angle here is what? The angle here is 90 degrees. Similarly, if I draw any other point, provided that it rests on the diameter, the angle that is subtended is what? Is equals to 90 degrees. The next property is what states that central angle is twice any inscribed angle subtended by the same arc. What this means is that if I have an arc, for example, as you can see AB here, and I subtend an angle here to the circumference, and I draw another two lines again to the center of the circle, that the angle subtended at the center is twice of the angle subtended at the what? At the circumference of the circle. Same thing applies here, just that my arc here is longer. So when I have here and I draw it to the circumference and I join some to the center, so the angle at the center is twice of the angle at the circumference. So a good example of this will be shown as follows. So let's assume I have a circle in which this is the center and I have it subtended from here like in this manner and in this manner, and I'm told that here is what? 50 degrees, and I'm asked what is this angle. So from this theorem, the angle that is subtended at the circumference, which is 15, is half of the angle subtended at the center. So the angle subtended at the center is twice of this. So the angle subtended there will be what? 100 degree. So another example, if I have a circle for instance now, and I have some subtended at the center like as shown here, and I'm told that the angle here is 200 degrees, and I'm asked what is the angle here. As I've mentioned, the angle subtended at the circumference is half of the angle subtended at the center, so the angle here will be equals to 100 degrees. So now on to the next property. This property 4 is referred to as cyclic quadrilateral. And what this means is that if you have a quadrilateral inscribed in a circle, the sum of opposite angles is equals to 180 degrees. For example, as you can see, a quadrilateral is a four-sided figure. So as you can see, you have a quadrilateral inscribed in this circle, meaning that all the edges of the quadrilateral are touching at some point of the circumference. So in that case, the opposite angles of the quadrilaterals, the sum of the opposite angles will be equals to what? 180 degree. So here, these are opposite angles A and C. So A plus C will be equals to 180 degrees. And similarly, D and B will be equals to 180 degrees likewise. So for instance, let's imagine a circle in which you have a quadrilateral in it, and you are told that this angle over here is 50 degrees, or let me say is 50 degrees, and you are told to find this angle over here. So now you know that in a cyclic quadrilateral, the sum of opposite angle are always what? Equal. So if I call here x, I know that what is equals to 180 degrees. So I know that here 50 plus x must be equals to 180 degrees. So x will be equals to 180 minus 50, and that's equals to 130 degrees. So the value of x here is 130 degrees. To recap, the angle of opposite angles in a cyclic quadrilateral, the sum of it must be equals to 180 degrees. So on to the next property, and this property has to do with the tangent of a circle. So to recap, imagine I draw a circle now and I draw a tangent to it. If you remember, a tangent is a line touching a circle. Then from the center of a circle, if I draw a straight line from that point to the tangent, you can see that the angle between the line and the tangent is equals to what? 90 degrees. So the angle between the tangent and a straight line drawn from the center is equals to 90 degrees. So imagine I have two points on a circle A and B, and I draw two tangents to pass through that point, and they intersect at the constant point C now. So I draw from point C two lines to touch the tangent of a circle. So the point at which they touch the circle, if I draw a line from that point to the center, you can see that that line represents my radius. And this property tells us that the length of AC, so the line AC is equals to the length of line BC. So this length is equal, and also the angle between here and here also will be equal to each other. That is what this property is all about. And the next property we'll talk about is the alternate segment theorem. So what this theorem tells us is that the angle between the tangent and the side of the triangle is equal to the opposite interior angle. So for example, if I draw a tangent to a circle, as you can see this line here is a tangent, and I have an angle x, and I have a triangle inscribed in the circle, that the angle in which this side of the triangle makes with the tangent is equals to the angle, the opposite interior angle. In this case, the opposite interior angle to here will be what? This angle over here. So if the angle between this triangle and the tangent is x over here, then the angle here will be x. Similarly, if the angle between this side of the triangle and the tangent is y, then the angle here, which is the opposite interior angle, will also be y. So let's apply all these theorems to try to solve some questions. So let's get started. So the first one, we're told that A, B, and C are points on the circumference of a circle with center O. Told to find x, the value of x. So as you can see, this line now lies on the what? On the diameter. So the line AC is the diameter because this line passes through the center. So in one of the theorem we discussed, we said that if an angle subtended on through the diameter of the circle, in this case, that the angle subtended on the circumference will be equal to 90 degrees. So from here, we know that the angle here will be what? 90 degrees. And now we have a triangle. And we know that the sum of angle in a triangle is 180 degrees. So we know that my angle x plus my angle here is 90 degrees plus 90 degrees plus 25 degrees is equals to 180 degrees. So x plus 90 plus 55 becomes 145 is equals to 180 degrees. So x becomes 180 minus 145 degrees, and that becomes what? 35 degrees. So the value of angle x is 35 degrees. Now on to the next example, and here we are told to find the value of x. So if you recall, the second theorem or the second property of arc tells us that if you have an angle or an arc, as you can see here, arc PQ, in which you have two lines subtended to the circumference, as you have QR and RS, and at the same time subtended to the center, as you can see here, that the angle at the center is 2 times of the angle on the circumference. So this value here is twice of this value over here. So now let me call here A and let me call here B. So this theorem tells me that what? That A is 2 times of B. Now I'm given that A is equals to what? X plus 70, and I'm given that B is equals to what? 2x minus 10. So I can substitute it here based on the property. Then I have what? X plus 70 must be equals to 2 into bracket 2x minus 10. So x plus 70, 2 times 2 becomes 4x, and 2 times 2 becomes minus 20. So if I bring this over here, I have x minus 4x is equals to minus 20 minus 70, and that becomes minus 3x is equals to minus 90. And if I divide both sides by minus 3, I have x being equals to what? 30. So the value of x here is 30 degrees. So now on to the next example. Here we are told that AB is a chord to the circle. So we have AB here, and we have an external point here, and we are told that TA and TB are tangents to the circle, and we are required to find the angle x in this example. So if you recall that when you have an external point and you have two tangents drawn to show that the angle here at this point is the same thing as the angle here. So that means if here is x, here also will definitely be x based on theory of tangents. So now we know that the sum of angle in a triangle is what? 180 degrees. So we can say x plus 38 is equals to 180 degrees. So we know that 2x will be equals to 180 minus 38, and we know that 2x will be equals to 142 degrees. So if I divide both sides by 2, I have the value of x being equals to 71 degrees. So the value of x is equals to 71 degrees. So now let's check out the next example. Here we are told that the diagram shows a circle with center O. C and D are points to the circumference. COE is a straight line. DE is a tangent. This line is a tangent. We are now told to find the value of y. So here we have to start manipulating. Now, if you will remember, if you have a circle, for instance, and I'm going to draw it over here to explain over here, and from the center you have a line coming over here and a line coming over here. As you know, definitely these two lines are what? They are the radius, and this gives me what? An isosceles triangle. So the angle that is here is going to be the same angle as what is here, because these two lines are the radius and they are equal. So the same thing applies here. Here we have OC. OC is a radius and OD is also a radii rather. So now we have these two lines being equal to each other. So what does that tell us of the angle? It means that the angle here must be equal to the angle over here. So if here is 25 degrees, here also must be equal to what? 25 degrees. Now that I've gotten here is equal to 25 degrees, we can find the angle that is over here, because this is the triangle. Now we know that for the sum of angle for triangle OCD must be equal to what? 180 degrees. So I can say that what? 25 plus 25 plus angle COD plus angle COD must be equals to 180 degrees. So angle COD will be what? 180 minus 50, which is equals to 130 degrees. So the angle over here is what? 130 degrees. Now that I've gotten this angle over here, I can find the angle over here, because I'm told that COE is a straight line. So if it's a straight line, I know that the sum of angle in a straight line is what? 180 degree. So let me call this angle here over A. So I know that the sum of this angle plus A must be equals to 180 degree. So I know that 130 plus A must be equals to 180 degrees. So I know that value of A will be 180 minus 130, and that is equals to 50 degrees. So the value of this angle here is equals to what? 50 degrees. And if you remember our discussion in which I told you that if you have a circle and you have a tangent to that circle and you draw a straight line from the center of the circle to the tangent, that the angle that will be subtended between that straight line and the tangent is going to be what? 90 degrees. So by definition, since I have this line OD coming from the center to the tangent, the angle here is what? Definitely going to be what? 90 degrees. So I know that here also is 90 degrees. So I know this angle, and I'm asked to find y. I know that the sum of angle in a triangle is what? 180 degree. So I can say that what? 50 plus 90 then plus angle y must be equals to 180 degrees. So 50 plus 90 is 140, then plus y must be equals to 180. So y is equals to 180 minus 140, and the value of y is equals to 40 degrees. So this angle over here is 40 degrees. So now on to the next example. We are told to find angle RPY. So now let's find angle RPY, and the way you go about it is that you look for those points RPY. So you have R here, you have P here, and you have Y here. So the place or the angle in that center place, which is at this angle P, is what we are looking for. So we are looking for this angle over here. So now if you look at carefully at this triangle that is inside this circle, you can see that what? That this is an isosceles triangle. And why is that? Because it has been indicated that this line over here is equal to this line over here. So as you can see, QR is equals to QP. And what do we say about isosceles triangle? If you have an isosceles triangle, then the angles at the base are also equal. So if here is 35 degrees, here also will be what? 35 degrees. So now we can find the value of angle Q or angle RQP. So let's call this angle for the sake of simplicity A. So I know that the sum of angle in a triangle is what? 180 degree. So I know that A plus 35 plus 35 is equals to 180. So I know that A plus 70 is equals to 180. So I know that A is 180 minus 70, and that is what? 110 degree. So the value of my angle A is what? 110 degree. Now if you remember the alternate tangent theorem, in which we were told that if we have a tangent subscribe a tangent to a cycle, that the angle in which an inscribed triangle or a set of a inscribed triangle makes with that tangent is equals to the angle in the opposite segment of the triangle. So that means this angle over here is the same thing as this angle over here. And since you have found here to be 110 degree, then invariably it means that here also is what? 110 degree. So angle RPY is equals to 110 degree. Now let's move on to the last question that we're going to be tackling. So here we are told to find the value of y, and this is a very convincing but very simple question to work with also. So let's get started. Now if you remember the last theorem we talked about, we told that if you have a tangent to a circle and a triangle inscribed in a circle, so here we have a triangle ABC inscribed in this triangle, that the angle that this side of the triangle makes with the tangent is equal to the angle in the opposite segment. So now we have an angle here that is what? 60 degree. So what it means that this angle over here is also what? 60 degrees based on that theorem. So now that I know that it's 60 degree, then I know that the sum of these two angles over here will be what? 60 plus 40. So the sum of this angle over here altogether will be what? 100 degrees. So the first thing is that based on that tangent theorem, I know that if here is 60 degree, the angle between this side of the triangle and the tangent inside the opposite segment will be 60 degree also. So now that I've gone here to be 60 degree, I can find the angle of this side considering this other triangle BCD. So and when I just add 60 degree to this 40, so the side of this triangle is what? 100 degree. So what I have now is something like this. Let me draw it out to avoid confusion. So I have this triangle now in which here is 25. I don't know this value. Here is D, here is my point C, and here is my point B. And I've gotten here to be 100 by adding the angle here and the angle here. So now we can find the angle here. So let me call that angle small d, the angle here, because we know that this is a triangle and the sum of angle in a triangle is what? 180 degrees. So we know that 25 plus 100 plus d is equals to 180. So d plus 125 is equals to 180. So d is equals to 180 minus 25, and that is equals to what? That is equals to 55 degrees. So angle D here is what? 55 degrees. So this angle over here is what? 55 degrees. Now I want you to look at something critical. If you look at, and let me draw it out so you won't get confused. So if you look at what is left now in this point B now, we have this triangle B subtended from to this circumference from here, and at this point C it comes here. Also from this point B over here, we have triangle moving over here, and from this point T it comes here. So based on the theorem property of arc, we know that if you have an arc BC in this case, that any two lines subtending of the circumference, the angle at the circumference is going to be the same thing. So we know that if here is 55 degrees as we've calculated, then by definition here also will be equal to what? 55 degrees based on that theorem. So therefore the value of y is equals to 55 degrees. So as you notice by now, one of the key things to solving questions that have to do with properties of line and angles and even quadrilaterals, polygons and circle theorem is knowledge of the theorems. So the first thing you have to do if you want to be able to tackle questions is be able to recall the theorems on spot. So I will encourage you to try to memorize and learn all the theorems. So now once you've done learning the theorems, the next thing you have to do is to know how to apply them. And the best way to know how to apply them is to solve as much questions as possible. So I will suggest that you go to your textbook and try to solve many questions so you'll be familiar with how to apply the theorem appropriately. So in the next section, we're going to be looking at some jam pass questions to see how to apply the concept that I've learned to solve practical questions.